Welcome to the Deep Dive. Today, we're tackling really one of the thorniest problems in AI right now. How do we actually know if these large language models are any good?
It's a huge challenge.
Yeah, like reliably evaluating them. If you can't tell how good a model really is or understand why one answer is better than another, it's super hard to make them better.
Exactly. Evaluation quality is genuinely a bottleneck for progress. You need robust ways to assess performance, especially for complex tasks.
So we're diving into a really interesting new paper from Meta AI. It's called J1, Incentivizing Thinking in LLM-as-a-Judge via Reinforcement Learning.
And it gets right at this. LLMs judging other LLMs, LLM-as-a-Judge, that's shown promise, particularly when they can explain their reasoning, the chain of thought idea.
Right. And this paper, J1, introduces a pretty clever method using reinforcement learning, RL, to basically train these judge models to think more effectively before they give a verdict.
They figured out a way to turn judgment tasks, even subjective ones, into verifiable tasks using synthetic data, so they know the ground truth.
Okay, synthetic data, that's key.
Yes, and then they use RL to specifically reward the judge for showing its reasoning steps before making the final call. It's about teaching the process of judging.
And the results seem quite strong. They trained these models, J1 Llama 8B and J1 Llama 70B, and found they outperform other models of the same size.
Yeah, even models distilled from much larger ones across several standard benchmarks.
And they even beat some bigger models on certain non-verifiable tasks, which is interesting.
And what's really fascinating, I think, is how they tackle bias, specifically position bias, where the judge changes its mind just based on the order of answers.
Yes, that old chestnut.
They introduce this concept of a Pointwise J1 judge, evaluating one response at a time, and they train it in a novel way using just pairwise data. It's surprisingly effective.
Okay, lots to unpack there. Let's get into the details of J1, how it works, its performance, and what it means for building better AI evaluators for all of you listening. So maybe let's start broad. Why is evaluation such a difficult thing right now? We have these incredibly powerful models, but judging them still feels messy.
Well, it's because the tasks we're asking them to do are so open-ended and complex. It's not just about getting facts right anymore.
Right.
It's about, helpfulness, safety, creativity, following nuanced instructions. A single number, a simple score just doesn't capture all that richness.
Like you lose the why.
Exactly. You need judges that can articulate why one response is better, show they're working, essentially. And that's where LLM-as-a-Judge comes in, using the model's own ability to generate that reasoning, that chain of thought.
People started just by prompting them, right? Like, think step by step before answering.
That was the initial approach. Then came fine-tuning methods, like DPO, direct preference optimization. That trains models directly on human preferences to get better alignment, including improving the reasoning steps.
Okay, so this paper builds on that. It asks, basically, can we go further with reinforcement learning? Can RL make the judges think even better, more consistently?
Precisely. The underlying idea is that models, maybe like people, make better judgments if they learn how to reason through the problem effectively. J1 is trying to explicitly train that reasoning process using RL rewards.
Okay, so here's where it gets really interesting. How do they actually do that? How do you train a judge with RL? Setting up rewards for, good thinking sounds abstract.
Yeah, it does. The key innovation, I think, is how they create verifiable judgment tasks. This is the tricky part for subjective prompts, like from, say, wild chat data.
Right. How do you verify which chat response is better?
They do it synthetically. For a given prompt, they generate two responses using another LLM. One is designed to be high quality, the other is intentionally made lower quality.
How do they make it lower quality?
Well, for something like wild chat, they might take the original instruction and have an LLM create a slightly noisy version, like misinterpret it slightly. Then they generate a response to that noisy instruction.
So it's likely to miss the original point.
Exactly. Or for math problems, it's easier. They just sample responses that lead to the wrong answer or have clear logical flaws.
Okay, so because they constructed the pair this way, they know the ground truth preference. Response A is meant to be better than response B.
Precisely. And this synthetic data generation avoids needing tons of expensive human annotations. It scales much better.
Big advantage. So they have this verifiable synthetic data, then they apply RL using GRPO. What's GRPO and how does it encourage the thinking part?
Right. GRPO Group Relative Policy Optimization. It's an online RL algorithm. One nice thing is it estimates baseline score from within the current batch of data, which can help stabilize training compared to methods needing a separate critic model. To get the thinking, they use what the paper calls a seed thinking prompt. It's basically part of the input prompt to the judge model during training.
What does it look like?
It essentially tells the model, okay, before you give your final verdict, first output your step-by-step reasoning inside these special tags, like think and think, then give your final judgment.
So it structures the output. It forces the model to generate the reasoning first.
Exactly. The RL algorithm then optimizes the entire generated sequence, the thoughts inside the tags, and the final verdict to maximize the reward.
And the rewards, is it just about getting the final AVSB decision right?
That's the primary reward, yeah. Verdict correctness. You get a 1 if the judge picks the synthetically correct response, 0 otherwise. Simple.
But you mentioned bias earlier, position bias.
Yes, and this is crucial.
Yeah.
For the standard pairwise judges, they add a verdict consistency reward. Position bias is a huge issue. You show A then B, the judge says A is better. You show B then A, it suddenly says B is better.
Yeah, that undermines trust completely.
So during training, they feed the model both orderings of a pair, A, B, and B, A, within the same batch. The model only gets this consistency reward if it gets the verdict correct, and if that verdict is the same, regardless of the presentation order.
That's really smart. It directly penalizes the model for being sensitive to the order.
It forces it to focus on the actual content and the reasoning, not superficial things like which response it saw first.
Now, the paper talks about different types of J1 judges. You mentioned pairwise and pointwise. Can you break down that difference?
Sure. So the main setup they explore is Pairwise J1. This is the standard LLM-as-a-Judge approach. You give it the prompt and 2 responses, A and B.
And it compares them.
Right. It outputs a verdict, A is better, B is a better, or maybe they're tied. Some versions might also output scores for A and B alongside the verdict, but the core task is the relative comparison.
Okay, standard enough. What about Pointwise J1? That sounds different.
It is, and it's a really interesting contribution. With Pointwise J1, you don't give it the pair. You give it 1 response at a time, along with the original prompt.
Just 1. And what does it output?
It outputs a quality score for that single response. Maybe a score from 0 to 10, for example.
And the advantage there is no position bias.
Exactly. By design, it's inherently position consistent. The score it gives response A shouldn't depend on whether it just saw response B or not, because it only ever sees 1 response at a time. There's no order to be biased by.
Okay, that makes intuitive sense. But wait, you said their training data was all pairwise. We know A is preferred to B. How do you train a model to score single responses using only comparative data?
That's the clever bit. They use something called distant supervision. They take their synthetic pair where they know A is better than B. They split this into 2 separate training examples for the Pointwise model. One example is prompt response A. The other is prompt response B. The Pointwise model is asked to generate a score for each. Now, they don't have a ground truth absolute score for A or B.
Right.
So the reward isn't about hitting a specific score. Instead, the model gets a reward of 1 only if the score it assigns to A when evaluated alone is higher than the score it assigns to B when evaluated alone.
So it learns to assign scores such that the relative ordering of the scores matches the known pairwise preference.
Exactly. It's learning to infer an absolute quality scale based purely on which response should score higher according to the pairwise ground truth.
That's quite elegant, actually, using pairwise labels to train a pointwise function.
And it works remarkably well according to their results. Table 3 in the paper shows that Pointwise J1 is much more position consistent than even their pairwise models that were trained with the consistency reward we discussed earlier.
Really? Even with the special training, the pairwise ones still flipped sometimes.
Yep. They reported inconsistency rates up to 20% for some pairwise models, meaning 1 in 5 judgments could still flip based on order. But for Pointwise J1, the equivalent issue is getting a tie, assigning the same score to both responses.
Okay, so a tie means it can't distinguish them based on score?
Right, and that tie rate was much lower, down to around 9% in some cases. A tie is arguably better than an inconsistent verdict.
Definitely seems less arbitrary.
And they also found, maybe unsurprisingly, that doing multiple runs at test time, like evaluating the same pair or response several times and averaging the scores, helps reduce inconsistencies or ties even further for both types of models. That's shown in Figure 4. So moving on to the actual performance. How well did J1 do? The benchmarks in Table 1 and Table 2 look pretty solid.
Yeah, they tested it across a range of judgment tasks, things like preference prediction, correctness evaluation, instruction following, using benchmarks like Judge Bench, RM Bench, Full Bench OWL.
And the J1 models generally perform very well. J1 Llama 7DB, for instance, beat evil planner.
Which use the same data, but DPO, right? Not RL.
Exactly. And it also outperformed DeepSeek GRM27B, which is interesting because that GRM model used significantly more training data.
So that really highlights the effectiveness of the J1 RL training approach itself, not just the data.
It seems so. It suggests incentivizing the thinking process explicitly with RL yields strong results, maybe more efficiently than just using preference optimization like DPO on the final outputs.
They also compared J1 against general thinking LLMs, like the distilled version of DeepSeek R1. How did that shake out?
J1 outperformed the DeepSeek R1 distilled llama across the board. On Judge Bench, which is pretty challenging, the J170B model saw like a 14% improvement over that distilled DeepSeek model.
Wow, okay. But what about the original massive DeepSeek R1, the 671 billion parameter one?
Well, the giant R1 was still better on the purely verifiable tasks. That's perhaps expected given its scale and likely training data.
Makes sense.
But interestingly, on the non-verifiable tasks, particularly those in the reward bench, chat hardened safety categories, so more subjective, nuanced judgments, J1 actually pulled ahead of the huge R1 model. That's in Table 8.
So J1 seems like a really strong generalist judge, maybe particularly good at the harder, more subjective evaluations where pure skill isn't the only answer.
That seems to be the implication, yeah. It holds its own or even excels against much larger models on those tricky tasks.
Did the Ablation Studies give any more clues about why it worked so well? Like, which parts of the method mattered most?
They did. Table 4 has some details. The simple reward setup, just positive reward for getting the verdict right, seemed to work best. Adding penalties or complex reward shaping didn't really improve things.
Keep it simple, huh?
Seems like it. Also, the exact wording of that seed thinking prompt didn't massively change the final accuracy. However,
Yes.
they found that a simpler seed prompt, the one shown in Figure 7, actually led to richer and more diverse reasoning patterns being generated by the judge model inside those think tags.
Oh, interesting. So less constrained prompts led to more exploratory thinking.
Kind of. They showed examples in Figure 2 where the judge would spontaneously do things like outline its evaluation criteria first, or generate its own reference answer to compare against, or even reevaluate its initial thoughts. The simply prompt seemed to encourage that more complex reasoning behavior.
That's fascinating. And did they look at the scores themselves, like how the Pointwise and Pairwise scores differ?
They did in Figure 5. It shows that while Pointwise J1 is more consistent positionally, the Pairwise J1 models tend to produce scores that are more sparse.
Sparse meaning?
Meaning bigger gaps between the score given to the chosen response and the score given to the rejected response within a pair.
Ah, okay. Why would that be?
Likely because the Pairwise model is explicitly trained to compare A and B side by side. That direct comparison makes the relative difference very clear during training, pushing the scores apart. The Pointwise model is inferring scores more indirectly from those pairwise signals, leading to maybe a smoother, less separated distribution.
Okay, so pulling all this together, what are the main takeaways for someone listening, maybe someone building or evaluating LLMs themselves? What does J1 really tell us?
I think the big one is that reinforcement learning, specifically focused on incentivizing the explicit thinking process, is a really potent way to train these LLM-as-a-Judge models.
Right, it's not just about the final answer, but rewarding the how.
Exactly, and it shows you can achieve state-of-the-art or near state-of-the-art judge performance using relatively modest amounts of high-quality synthetic data, which is a big deal for practicality.
And the bias aspect seems critical. It offers real strategies, especially that Pointwise approach.
Yes, the Pointwise J1 trained using distant supervision from pairwise data. That's a really significant finding. It presents a clear path towards building judges that are inherently resistant to position bias, tackling a long-standing headache in LLM evaluation.
That technique alone feels like it could be applied elsewhere too.
Potentially, yeah. It's a clever way to leverage comparative data.
So overall, this deep dive into J1, it really paints a clearer picture. It shows us how we might build AI evaluators that are not just accurate, but also more reliable, more robust, and maybe even more understandable because we're training their reasoning.
It feels like a definite step forward
towards aligning these models better, understanding them better.
And it does raise a really interesting question, doesn't it? If we succeed in training judges to provide detailed, structured, step-by-step reasoning, does that change how we should fundamentally trust their evaluations?
How so?
Well, should we move beyond just looking at the final verdict or the final score and instead focus on scrutinizing the judge's own chain of thought? Is the quality of the reasoning itself the ultimate measure of whether we should trust the judgment?
Judging the judge's thinking, not just its answer, that is a powerful thought to ponder. We hope this deep dive into the J1 paper has been valuable and given you some food for thought.